Welcome to Diwakar Physics. So in this video we'll discuss about the multiple choice questions from alternating current chapter. Okay, so it will be useful for ISC class 12 students and CBSE class 12 also. So let us start. So first question is like this: an alternating EMF of 100 volt is applied to a circuit containing a resistance of 40 ohm and inductance L in series. The current is found to lag behind the voltage by an angle A equals to tan inverse 3 by 4. Then first question is, the inductive reactance in this case is 40 ohm, 30 ohm, 50 and 10 root to 5 ohm. Okay, so as the angle is given here, so current is lagging behind this angle, so then you can use the formula tan phi equals to, or tan A equals to XL by R. Okay, so this is the basic formula for LR circuit. Then you can write tan phi, so tan inverse 3 by 4. Then XL will be I. So XL you have to find, so keep XL as XL only, and R is given, you see, so R is given 40, so this value is 3 by 4. Okay, tan phi is given 3 by 4, so that's why you can put the value 3 by 4 XL by R. R is given 40 ohm. Okay, 40 ohm is given in the question. Then XL equals to 3 into 40 by 4, so that is 30 ohm. So that's why your the second option is correct. Yeah, so 30 ohm is the inductive reactance XL. Okay, then we'll go to the next question. The next question is impedance of the circuit. So here you know that inductance is there and resistance is there. Okay, so two components are there. Then the impedance of the circuit will be root over R square plus XL square. The capacitor is not there, so XL square plus R square. Then we have the values of both. R is 40 and XL we have got 30. So you just solve it. So by solving we get root over 1600 plus 900 equals to root over 2500, which gives 50 ohm. Okay, so this is the answer. So which option is correct? So you can choose, this is the option 50 ohm. Okay, so impedance of the circuit, so total resistance is 50 ohm. Now next question, the current flowing through the circuit. Okay, current flowing through the circuit. So as the total impedance is 50, then how to find the current? I is equal to the voltage. Okay, so V by Z. I is equal to V by R, so you can compare that way. Then V is 100 and Z is 50, so that's why 2 ampere current will come. So 2 ampere current you can mark. So this is the correct 2 ampere. Okay, now next we have fourth part. If the inductance has the value of 0.096 Henry and pi value is given, the approximate frequency of the applied EMF. So 40 Hertz, 50 Hertz, 30 and none of this. So here L is given, pi is given, then you have to find the frequency. So as you know, we have XL here, so XL is equal to omega L we can take, and from here we can find the frequency. So omega is equal to 2 pi into frequency into L. Then frequency will be XL by 2 pi L. XL by 2 pi L. So XL we have already got 30. So 30 upon 2 into 3.14 into L. So L is given 0.096. So then by putting the values and solving, so we get 50 Hertz here. So if you solve this, you get something 49.7 something, then approximately is 50 Hertz. So your option is 50 Hertz. So this way we can solve this question. Okay, we'll go to the second question. So second question is like this: 2 microfarad capacitor, 100 ohm resistor and 8 Henry inductor are connected with AC source at a certain frequency of about 40 Hertz. For this AC source, the current drawn in the circuit is maximum. So if the peak value of EMF is 200 volt, what is the peak value of current in the circuit? Okay, so current depends on the total impedance, and here one more thing you can consider here: the current drawn in the circuit is maximum. That means uh, is the condition of resonance. Okay, so that's why when current is maximum, so impedance is minimum. That's why we can take I is equal to I peak current. So I naught is equal to V naught by Z. Okay, this is the general formula. But in this case, current is maximum, so impedance is minimum, and that is equal to resistance. Because generally we have Z equals to R square XL, XL minus XC whole square. But when current is maximum, then this Z is minimum. That's why this value XL is equal to XC. So this value will be 0. Then Z is equal to R. So this is the minimum resist or impedance in LCR circuit. So in place of Z you can put R. So how much is V naught? 200, and R is given. So here R is given 100. So 200 by 100. So that is 2 ampere. So peak value of current is 2 ampere you can take. Okay. So the option is 2 ampere here. Okay. So next question we say, what is the phase relation between voltage across inductor and resistor? Pi by 4, pi by 3, pi by 2, none of this. So in LCR circuit what happens? So you remember one thing. So in capacitor C, in capacitor current leads. Okay, C leads, and Hindi you can remember capacitor C आगे means in capacitor current leads the voltage by 90 degree. Okay, so that is what you can remember. C in capacitor current आगे रहता है. Okay, so now in inductor and resistor, so it is like this. Suppose this is VR and IR, they are in the same phase. Okay, now in capacitance a current आ गए, so ये BC हो जाएगा and VL यहाँ होगा, VL यानी इंडक्टर में वोल्टेज करंट पीछे. सॉरी ये IC हो जाएगा। कैपेसिटेंस में करंट आगे और ये भी है, और कैपेसिटर में करंट आगे और इसमें IL, इसमें पीछे होगा। ओके। यदि हम वोल्टेज के बारे में देखेंगे तो कैपेसिटेंस में करंट आगे तो वोल्टेज पीछे होगा। ठीक है, वोल्टेज पीछे C में, ये 90 डिग्री पीछे, और L में वोल्टेज आगे। ठीक है, एंगल ऐसे मेजर करेंगे और एंटी क्लॉकवाइज। तो ये आप याद रखेंगे। तो अभी ये क्वेश्चन में आप देखिए, व्हाट इज द रिलेशन बिटवीन द फेज रिलेशन बिटवीन वोल्टेज एंड इंडक्टर, वोल्टेज अक्रॉस इंडक्टर एंड रेजिस्टर। तो ये 90 डिग्री है। ओके, π/2 ये हो गया। तो सी ऑप्शन। नेक्स्ट क्वेश्चन है, व्हाट इज द फेज डिफरेंस बिटवीन वोल्टेज अक्रॉस इंडक्टर एंड कैपेसिटर। देखिए, अब इंडक्टर और कैपेसिटर में वोल्टेज के बारे में बोला, तो वोल्टेज ऑफ इंडक्टर यहाँ है 90 डिग्री आगे, यहाँ से ये 0 है, और ये VC 90 डिग्री पीछे है। ठीक है, एंगल यहाँ से शुरू होता है, तो इस डायरेक्शन में शुरू होता है, ये पीछे है, रेजिस्टेंस है, ये पीछे रहता है। तो ये 90 डिग्री आगे, ये 90 डिग्री पीछे। दैट मीन्स VL और VC का जो फेस डिफरेंस है वो 180 डिग्री हो गया, π/2 प्लस π/2 पाई हो गया। तो ये आंसर राइट होगा। ओके, तो याद रखना है कैपेसिटेंस में करंट आगे, सो करंट लीड्स इन कैपेसिटर, CC लीड्स और CC आगे। ओके, तो ये याद रखेंगे, आपको आसान हो जाएगा। ओके, we'll go to the next question. An AC generator generating an EMF of this is connected to a series combination of 16 microfarad capacitor, 1 Henry inductor, 100 ohm resistor. What is the frequency of AC? यहाँ पर ये जनरेशन किया है ना, ये E = 300 sin 100 πt। तो इसको हम ऐसे लिख सकते हैं, E = E0 sin ओमेगा टी। तो ये जनरल एक्सप्रेशन है EMF का। सो E0 sin ओमेगा होता है 2πf t, बिकॉज ओमेगा इज बेसिकली θ/t होता है ना। अभी थीटा जब 2π लेंगे तो ये t हो जाएगा कैपिटल T, टाइम पीरियड, एंड 1/t इज f, सो 2πf, सो 2πf होगा। तभी इसको कंपेयर कीजिए। अभी यहाँ पर क्या दिया है, EMF का दिया है वैल्यू, देख सकते हैं 300 sin 100 πt। तो EMF 300 sin 100 πt, that means this 100 pi is 2πf, then pi cancel, then f equals to 100/2, 50 hertz. So frequency is 50 hertz, so 1 mark, so you can mark this 50 hertz. So next question is, from the graph of EMF generated by an AC generator versus time, find the frequency. So frequency is equal to 1/t. Now here one complete cycle is completed after 0.1 second. So you can see, so time capital T is 0.1 second, then f is equal to 1/t, so 1/0.1, so 10, so 10 hertz. Okay, so answer is 10 hertz. So this option you can mark it correct. Next question is, a graph showing variation in impedance Z of a series LCR circuit with frequency f of alternating EMF applied to it. What is the minimum value of impedance? R Z is equal to root over R square plus XL minus XC whole square. Z minimum XL is equal to XC. So here, what is the minimum value of impedance? So this graph is showing this is decreasing and again it is increasing. That means when this resonance condition is fulfilled, then this is the minimum uh, impedance. And this Z minimum will be equal to the resistance whatever you are connecting here in the circuit. So that will be equal to R. Okay, because this XL minus XC is 0, then Z will be equal to R. Okay, so next question is, which of the following is not the characteristics of resonance in an LCR series circuit? So XL minus XL is equal to XC, so this is okay, this is true. Then just you replace the value XL is omega L, XC is equal to 1 by omega C, so this is also correct. But here you see 2 pi FL, so XL is 2 pi FL, that is okay. But here it should be 1 by 2 pi FC, but they have given this is equal to this, so this is wrong. Okay, so this is not the correct characteristic for resonance. And this is also correct, because if you solve this and replace the omega is equal to 2 pi f, then you get this expression. So only this is wrong. Okay, so next question is, which of the following graph represent the variation of current with frequency in an AC circuit containing a pure capacitor? Pure capacitor. Okay, in capacitor XC, the reactance is 1 by omega C, that is XC is inversely proportional to frequency. If frequency increases, then resistance decreases, and if resistance decreases, current increases. So that means F is directly proportional to I, or I is directly proportional to F. So this graph is okay. Okay, next question. The instantaneous values of EMF and the current in a series AC circuit are given. Then it is necessarily RL circuit, RC circuit, LCR circuit, and can be RC or LCR circuit. So here you can see that current is leading. So current is leading the voltage by pi by 3. Then capacitance, करंट आगे, कैपेसिटेंस में करंट आगे रहता है, तो इट कैन बी आरसी सर्किट और इट कैन बी LCR circuit also. Okay, so a fourth option is correct because current is leading, so it is capacitive circuit. Okay, so RC या LCR दोनों में से हो सकता है, RL नहीं होगा, जिसमें इंडक्टर में करंट पीछे रहता है. ठीक है, so that way you can decide. Okay, so next question you can say, an alternating voltage source of variable angular frequency omega and fixed amplitude V is connected to series combination of capacitance and electric bulb of resistance R. So when omega is increased, now if you increase the omega, then what will happen? Bulb glows dimmer, bulb glows brighter, net impedance of the circuit remains unchanged, total impedance of the circuit increases. Now here what happens, this is capacitance and resistance. So Z will be equal to R square plus 1 by omega C square. Now when we increase omega, then this value will decrease this value will decrease and Z will decrease. If Z will decrease, if the impedance decreases, then current increases in the circuit. So that's why the bulb glows brighter. So this is the correct answer. So here Z is decreasing because of increasing value of omega. So second option is correct. Okay, next question. Sinusoidal voltage of peak value 283 volt and frequency 50 hertz is applied to a series LCR circuit in which R is equal to 3 ohm, L is given, C is given. Then the power distributed in the resonant condition will be 39.7 kilowatt, 26.7 kilowatt, 13.35 kilowatt and 0. So here the resonance condition is given and the value of LCR given, voltage, peak value of the voltage is also given. Then what is the power dissipated? The resonance condition. So we have formula power equals to V naught square by 2R, or you can use RMS value also, V RMS square by R. But here peak value is given, then we can use this formula. Okay, so we can use the value, and you know this resistance Z is equal to resistance at resonance condition. So that's why V naught square by 2R I have taken. Okay, this is for resistive circuit or LCR circuit at resonance condition. So that's why we can use this formula. So 283 into 283 by 2 into R. R is 3. Then we get, solving this, we'll get 13,348.17 watt. So which is approximately equal to 13.348.17 kilowatt. So they have given the options in kilowatt, so we can convert, then compare. 13.348. So that means, so this option will be correct. 13.35. Okay, so you can understand 348, that we can write 35. So this is matching. So this is the answer. The next question is, the impedance of a capacitor of capacitance C in an AC circuit using source of frequency n hertz is 2 pi nc, 1 by 2 pi nc, c by 2 pi n and 2 pi n by c. So here we have xc equals to 1 by omega c. So 1 by 2 pi f c. Then this option will be 2 pi nc, because frequency is given n. 2 pi nc. So this option is correct. Next question is, what is the value of impedance of a resonance series LCR circuit? Equal to the value of omega L, equal to the value of R, equal to the value of 1 by omega c, none of the above. So this option will be correct, as we have discussed before. At resonance, Z is equal to R. Okay. Next question. 100 ohm resistor is connected to 220 volt 50 hertz AC supply. The RMS value of current in the circuit. So what is the RMS value of current in the circuit? RMS current. So here resistance is given 100 ohm and VRMS is given 220 volt. Then what is IRMS? VRMS by R. So this is 220 divided by 100. Then you get 2.2 ampere. Okay, so this option is correct. Second option is correct. And next question is the average power consumed over a full cycle. Average power consumed over a full cycle in the resistance. So the formula you can use ERMS, VRMS into IRMS. Power is equal to V into I. So both the values we have 220 into 2.2. So 484 watt. So this is correct, 484 watt. Next question, 60 microfarad capacitor is connected to 110 volt and 60 hertz AC supply. The RMS value of current you have to find. RMS value of current. So here IRMS will be equal to VRMS by reactance of capacitor XC. So that means we have to find the value of XC, then we can use this formula. So this is 110 volt is the VRMS. So VRMS 1 by omega C. So VRMS into frequency is given, so we'll write 2 pi F into C. So this will give the value of current. So then VRMS is how much? 110, 2 into 3.14, frequency 60, and capacitor is 60 microfarad. 60 into 10 to the power minus 6. Then solving all, we will get 2.49 ampere. Okay, so that's why this option is correct. So here you can find XC first separately, then you can divide. So that also you can do. Okay, next question. The reactance of a capacitance X is, C is X. If both the frequency and capacitance be doubled, then new reactance will be X, 2X, 4X, X by 4. Okay, so same way from here only you can do X C equals to 1 by omega C. So frequency is also doubled, or you can say 1 by 2 pi FC. If frequency is doubled and C is also doubled, then it becomes 1/4. Multiply by 2, multiply by 2. So that's why, so X by 4. X by 4 will be the answer. So this option is correct. X by 4. Because both the frequency and capacitance are inversely proportional to the reactance. Next question is, what is the value of inductance L for which the current is maximum in a series LCR circuit with capacitance 10 microfarad and omega is 1000 per second. Okay, then here resonance condition is there again, so you can see that current is maximum. Okay, then during resonance condition, so what is the relation between L and C, so that you can use, because the value of C is given, omega is given, then using that concept you can solve it, like XL is equal to XC. This is the condition for resonance. So omega L is equal to 1 by omega C. So L will be equal to 1 by omega square C. So if you put the values, then you will get the answer 1000 square into C. C is, how much is C? 10 microfarad. 10 into 10 to the power minus 6. Then 10 to the power 6 you can take up, and here 10 to the power 6 into 10. So here 3 zeros are there, so 3 zeros square, that means you will get 10 to the power 6. Then this much Henry you will get. Then options are given in millihenries, so you multiply with 1000. Then 100 millihenry is the answer. 100 millihenry. So this option is correct. Okay. So this way you can solve the questions based on AC circuits, AC current. Okay. Thank you for watching my video.